Alright guys, in this video what I'd like to do is talk to you about AC to DC power converters. The main type that we will be using will look like this, or exactly like this, because this is the exact model we are going to be using. In the end, I'm going to explain how they operate and how they work, and at the end of the video I'm actually going to show you wired up and what I expect for this lab, okay? So, walking through this, what it does is it changes 120 AC volts down to 24 DC volts. So most of the time with DC you're not going to be working at a higher end voltage like 120. You're going to be mostly working at that 24 volts or 12 volts, okay? So how it's all going to start, and I've got the schematic of what's actually inside here drawn up on the board behind me. It's quite big, so I'm going to kind of walk through it, and it might be a little bit hard for me to show on camera, but I'm going to try to get it all in there. Now, we know, we've already seen this symbol right here, because in the last lab, I had you guys wire transformers. So this is a transformer right here. Now this transformer is not like the one that we have in the other activities. It actually drops it down to about 36 volts. So it goes 120 and then it drops down to 36 volts, okay? It's just a much more manageable size voltage for what we're gonna do next to it, okay? The next thing that we're going to go into is what they call a rectifier bridge, okay? And what this is doing is it's actually taking that AC wave and it's knocking off all the negatives and positives so that it can end coming out as a DC, okay? And it's kind of hard to explain because if you follow one side, what happens is it's going to go here and it's going to go through this diode. And this is a symbol for a diode. And we're going to talk a lot more about this kind of stuff in like module 6, I believe, where we actually get into electronics, okay? So, but I'm just trying to give you that background so you understand how this works. So it's going to go through the diode, and then it's going to go out, all the way out to the load, and then it's going to come back, and it's going to come in through the other wire that comes in, through this diode, making it back to a ground, okay? So it's gonna, what it's doing is it's giving it just a path so that it has to become DC, okay? And I'm not gonna get too deep into explanation on this. There's some great animations of these on the internet, and I'm gonna try to link a couple of those for you guys in the bottom of this page, all right? So, moving on. So we've already knocked it down, but the wave is still kind of wiggly as it comes out, right? It's not gonna be perfect DC coming out of this. So what we do is we then will run it through what these are called our capacitors. Now a capacitor is much like a battery or accumulator, maybe a hydraulic system. What happens is the electricity comes in and it actually fills up both sides and it just kind of supercharges this capacitor, and what it does is it smooths out that wave, all right? So we run it through multiples of these capacitors, and there's no electrical connection to these, and they do kind of look a lot like a contact in a relay, but they are a lot bigger as far as these plates are concerned, okay? So again, we're going to talk about these guys in our electronics class, just trying to give some background. So it's trying to it's charging that up so that way it smooths that wire or that signal even more. And then over here what happens is it gets to what they call a voltage regulator. Now the voltage regulator is actually going to regulate how many volts are coming out of it. So more than likely we're not going to have a perfect 12 volts DC right here. What's going to happen is it's going to get to this regulator, it's going to take whatever amount is coming in and only let the specific amount come out. So it'll be something like 12 volts at this point, or maybe a 24 volt. I believe ours is 24 volts. It'll be 24 volts coming out. Maybe it was 36 or 30 or something over here. So it's going to go through there, going to turn it to 12. And then we're going to run it through a couple more capacitors, all right? And again, it's just trying to keep smoothing that out, all right? And then at the end, we have two wires or terminals that we could plug into that are going to be our negative and our positive, all right? If you look at our actual specific AC to DC power source here, you're going to see that our terminals coming out as a DC are on top, and our ones here at the bottom are going to be our 120 volts coming in. So that's the explanation, kind of how this one works. It's a very quick explanation, and I will go into more in-depth detail in our electronics class, and we will probably actually even build one of these later on down the road. But what I'm going to do now is I'm going to flip over to my trainer. I'm going to go ahead and I'm going to already have it wired up, and I'm going to show you how I'd like you to submit this lab. And I want to also talk a little bit more about the terminals and what they each mean, all right? So let's go over and check that out. All right, guys, so I got this thing set up, and I do have the power on at this point. And you can see on my multimeter that I do have DC 24 volts, okay? And I am plugged into the positive V and the negative V to get that, all right? Now you notice that it says negative 24 volts. Well, if I took these terminals out and flipped them over, it would actually change that, or I could actually unhook these and just swap them because they are identical. And you can see that it's now reading positive. So I would have been going the wrong polarity for my leads, all right? Which is no big deal. If you turn it in and you have the negative in there, it won't bother me. But now there is a couple things I do want to point out before you guys start this lab. One thing is, you'll notice in the bottom here, it has L, N, and then it has the symbol for a ground. So I'm going to go ahead and let's try to zoom in on that maybe a little bit better. I don't know if you can see it. So you can see our L, our N, and our ground symbol, okay? Now the L stands for our line voltage, so this would be our hot. Notice I have the black wire. I don't know if you can see it underneath here. The black wire is connected to the L. N is for our neutral. You see that our white wire is connected to the neutral, and our ground is the green here, and it is connected to the ground symbol, all right? I don't know if I've been over that with you guys, so I wanted to make sure I pointed this out. Now, this is just like a transformer in the sense that after it, I would need to put a breaker. You can see that I have my breaker hooked up to my transformer over here. We are going to be using this one a lot more with the transformer in this class. When we move into areas such as PLCs, we're going to be using this a lot more, all right? So go ahead and submit me a picture of your leads stuck into our AC to DC converter, or power source, I'm sorry, and the face of this multimeter. Now I want to make this very clear because I've gotten some submissions that are kind of annoying to me. If the face of the multimeter is not in DC, it does not say 24 volts, I will not give you credit for it. So please make sure you got this set up correctly, all right? So go ahead and get started. Good luck.